Calculating box fill correctly is crucial for safe and compliant electrical installations. When determining the number of conductors within a box, the National Electrical Code, specifically Section 314.16b4, addresses how equipment grounding conductors are counted. Generally, all equipment grounding conductors that enter a box are counted as a single conductor for box fill calculations. However, there's an exception to this rule. The exception comes into play when the equipment grounding conductors terminate at device terminals within the box. In that scenario, each individual grounding conductor is counted separately. Therefore, understanding this distinction is important for accurate box fill calculations. Let's delve into the specifics. Imagine a scenario where you have multiple equipment grounding conductors entering an electrical box. These conductors are all connected together with a wire connector, commonly a pigtail, and a single conductor then connects to the grounding terminal of a device such as a receptacle or switch. In this case, all of those equipment grounding conductors, regardless of how many there are counted as just one conductor for the purpose of box fill calculations. This is because they are effectively being treated as a single circuit within the box's volume. On the other hand, if each of those equipment grounding conductors were individually connected to separate grounding terminals on different devices within the box, then each one must be counted separately. To clarify further, consider a single gang electrical box containing 3 12 American wire gauge with ground, non-metallic sheathed cables, also known as ROMICs. According to the code, each 12 American wire gauge conductor has a volume allowance based on Table 314.16b. For 12 American wire gauge conductors, the volume allowance is 2.25 cubic inches per conductor. Now let's calculate the box fill. Firstly, count the current carrying conductors. Each ROMICS cable has 2 current carrying conductors, a hot and the neutral, giving us a total of 6 current carrying conductors from the 3 cables. Secondly, account for the equipment grounding conductors. If all 3 equipment grounding conductors are connected together in pigtail to a single grounding terminal on a device, they count as one conductor. Thirdly, account for device yokes. Devices such as switches or receptacles that are mounted on a single yoke count as 2 conductors, based on the largest conductor connected to the device. In this case, since we're using 12 American wire gauge wire, the device yoke counts as 2 12 American wire gauge conductors. Therefore, the total conductor count would be 6 current carrying conductors plus 1 for the equipment grounding conductors plus 2 for the device yoke, equaling 9 conductors. Now calculate the total box fill required. Multiply the number of conductors by the volume allowance per conductor. In this case, 9 conductors multiplied by 2.25 cubic inches per conductor equals 20.25 cubic inches. This means that the electrical box must have a minimum volume of 20.25 cubic inches to be code compliant. Now let's consider a different scenario. Suppose, instead of connecting all the grounding conductors together, each of the 3 equipment grounding conductors is connected directly to a separate grounding terminal on the device, such as a grounding type receptacle with back wire terminals. In this case, each equipment grounding conductor must be counted individually. This would change the calculation as follows. Firstly, the 3 12 American wire gauge ROMICS cables still contribute 6 current carrying conductors. Secondly, since each of the 3 equipment grounding conductors is individually connected to the device, they are counted as 3 conductors instead of 1. Thirdly, the device yoke still counts as 2 conductors. So, the total conductor count in this scenario would be 6 current carrying conductors plus 3 equipment grounding conductors plus 2 for the device yoke, totaling 11 conductors. The required box volume would then be 11 conductors multiplied by 2.25 cubic inches per conductor, which equals 24.75 cubic inches. Therefore, in this situation, you would need an electrical box with a minimum volume of 24.75 cubic inches to comply with the National Electrical Code. It is important to choose the correct size electrical box for the wiring and devices being installed. Overfilling an electrical box can lead to several problems, including difficulty in making connections, potential damage to the conductors from overcrowding, and increased risk of overheating, which can be a fire hazard. National Electrical Code Section 314.16 provides detailed rules for calculating box fill, and it's essential to understand and follow these rules to ensure a safe and compliant electrical installation. Other factors to consider when calculating box fill include conductor size, the number of devices in the box, and any internal cable clamps or fittings. Each of these factors contributes to the total volume occupied within the box, and all must be accounted for to determine the correct box size. When dealing with multiple cable entries into a box, remember that each conductor entering the box must be counted, with the exception of the equipment grounding conductors as previously explained. Furthermore, any splices or terminations within the box also take up space and contribute to the overall fill. Always consult the National Electrical Code and local amendments for the most accurate and up-to-date information on box fill requirements. Proper box fill calculation is not merely a matter of compliance, it is an essential aspect of electrical safety. By adhering to the code requirements and paying close attention to the details of each installation, electrical professionals can ensure the safety and reliability of electrical systems for years to come. Another example is if you have a 4-square box that has two 12 American wire gauge with ground, non-metallic sheath cables entering it. Both grounds are connected with a wire connector, and a 12 American wire gauge conductor is pigtailed and connected to a metal box. How many conductors do we count? The two current carrying conductors from each cable will equal 4. The grounds are connected together, so we count 1. Then, since we are connecting to the metal box, we add one more conductor. This is a total of 6 conductors. Then 6 conductors multiplied by 2.25 cubic inches is 13.5 cubic inches that the devices and wiring can take up inside the box. If there is a receptacle added, then you would add 2 more conductors to the 6 and multiply 8 conductors by 2.25 cubic inches, totaling 18 cubic inches that devices and wiring can take up inside the box.